Right now, massive AI systems are quietly processing data. They're processing 7 billion hours of animal behavior data. Beat. It's completely invisible to our daily human lives. Welcome to the deep dive. We're mapping a truly profound technological shift today. Artificial intelligence is rapidly breaking out of your standard web browser.
Yeah, it really is. It's evolving from isolated screen-based chatbots into something else entirely.
Exactly. We're seeing a rapid move toward massive physical systems, and the immense scale of memory required is completely unprecedented. First, we'll explore physical AI actively herding real-world livestock.
Right.
Then, we explored tech giants warring over persistent digital memory. Next, we observe the sobering ground-level reality of AI misuse. Finally, we examine the highly complex multi-agent frameworks being built today.
We have a really fascinating stack of sources to unpack today. The evolution of these underlying systems is accelerating at a staggering pace. We're moving way beyond simple text generation on a flat screen. The models are, actively touching the physical world right now.
Let's start with the massive physical scale of artificial intelligence. It's moving directly into the physical world at a mind-bending scale. We have a detailed report here on a tech startup called Halter. They're a New Zealand company building AI collars to guide cattle.
Right, and they natively call this tracking system the Cowgorithm. It's a slightly strange but incredibly accurate name for it. They created highly advanced solar-powered smart collars for the actual animals.
These effectively replace traditional physical fences on massive agricultural farms. Instead of building wooden fences, farmers manage cattle remotely through an app. Before this technology existed, farmers relied entirely on physical wooden boundaries. Building and maintaining those physical fences requires massive amounts of labor. You have to drive heavy wooden posts deep into the earth.
Exactly.
You string miles of heavy wire across massive open agricultural fields. It's an incredibly slow and highly resource-intensive process overall. Halter completely eliminates that entire physical infrastructure overnight with a smart collar.
Yeah, the collar sits comfortably around the physical neck of the cow. It uses highly precise GPS tracking to understand its exact location continuously. The farmer simply draws a digital polygon on their mobile tablet device.
Oh.
That digital shape instantly becomes an invisible barrier for the herd. Physical barriers are simply no longer needed out in those open fields.
The collars create complex virtual fencing without any visible physical boundaries. They allow remote herding through direct mobile app controls and gentle vibrations.
Right.
They also provide continuous real-time health and behavior monitoring for the herd. But how exactly does this device completely replace a solid wooden fence?
The smart collar uses specific audio cues and mild pulses. If a cow approaches the virtual boundary, it hears a warning sound. If it ignores the sound, it gets a very gentle vibration pulse. The automated grazing optimization is based entirely on continuous AI data insights. And here's where the sheer scale of data collection gets completely staggering.
How much data are we actually talking about here?
Each individual collar sends data back to the central processing system constantly. It transmits over 6,000 distinct data points every single minute.
Whoa, imagine scaling to 1 billion queries like that. That's over 100 data points recorded every single second globally. It's tracking exactly how the physical animals are moving across the terrain. It monitors precisely how they eat and chew their food daily. Managing a physical herd with these collars is like stacking Lego blocks of data. You're carefully snapping together tiny data points to construct a new reality. You build an entire physical agricultural ecosystem directly from continuous data fragments.
Exactly. You're building a real-world digital map from tiny behavioral fragments. Over time, this immense volume of data improves the core predictive AI model. It reliably predicts specific health issues long before a human farmer notices. It optimizes daily pasture usage to seamlessly maximize overall farm efficiency.
The platform has accumulated over 7 billion hours of historical data already. That's 7 billion hours of pure animal behavior data fully processed computationally. And global financial markets are definitely noticing this massive technological shift today.
Yeah, the sources show Halter is extremely close to a massive funding round. Peter Thiel's Founders Fund is reportedly leading this massive financial investment entirely. This easily pushes their company valuation toward a staggering $2 billion.
That's up from a $1 billion valuation just last year alone.
Right. Peter Thiel has a historical track record of predicting massive societal shifts. His highly influential fund clearly sees agriculture as the next major technological frontier. They genuinely believe predictive software will automate the physical world of farming next.
And Jeff Bezos clearly recognizes this exact same massive logistical opportunity, too. He's currently in early discussions to build something very similar at scale. Oh. He's reportedly raising a massive AI automation fund for physical logistics globally.
He's actively aiming to build a massive $100 billion investment fund.
That specific financial number is historically unprecedented in scale. They want to advance physical AI automation technologies across various global industries. The specific target companies aren't fully detailed in our current sources quite yet, but the underlying trend toward massive physical automation is completely undeniable today. So what does capturing all this physical data actually mean? What does it mean for the future of AI models?
It means artificial intelligence will finally understand actual real-world physics organically.
Models are comprehending physical reality now, not just text. 2-sec silence. We need to explore the massive memory and ecosystem war next. To process physical data effectively, AI requires completely flawless digital memory. These systems require massive, persistent coding ecosystems to function properly.
Right, we're currently witnessing a massive corporate war over persistent digital memory. OpenAI just recently rolled out their brand new ChatGPT Library feature globally. It's a dedicated background digital space that automatically saves your personal files. It silently saves your uploaded documents across all your different active chats.
If you upload a complex spreadsheet Monday, the AI perfectly remembers it Friday.
Exactly.
But there's a very crucial detail hidden deep inside this system update. Even explicitly deleted conversations won't remove those saved files from the corporate server. The files stubbornly stay inside your personal library permanently by default. Beat. Let's pause and really unpack that. If even deleted files stay saved in their system indefinitely without clear consent, are we fundamentally losing control over our own personal digital data entirely?
It's a very valid concern regarding long-term user data retention policies. From a pure digital privacy standpoint, permanent default retention is highly problematic overall. But from a strict daily workflow perspective, persistent memory is entirely necessary today. It permanently stops the AI from constantly forgetting your core project instructions.
To be honest, I still wrestle with prompt drift myself constantly. You write a perfectly crafted system prompt for a highly complex coding task. The AI strictly follows your complex rules perfectly for the first few responses. But as the conversation grows longer, it slowly forgets your initial constraints. It starts writing incredibly lazy code that fundamentally breaks your established formatting rules.
Yeah.
Beat. Persistent memory acts as an unbreakable digital anchor for your ongoing projects.
Exactly, and persistent memory permanently solves that incredibly frustrating problem for developers. But it also creates a massive digital ecosystem lock-in for the average user. If OpenAI holds all your historical context, you'll probably never leave them. Google is already preparing a major strategic countermove to prevent this scenario.
The sources say Google is currently preparing a brand new tool for Gemini. It'll seamlessly import your entire ChatGPT memory and chat history directly. Just easily copy a specific prompt or upload an export file directly.
Yeah.
Google desperately wants to steal that highly valuable persistent memory away entirely.
And Apple is entering this massive ecosystem memory war very soon as well. Apple just officially confirmed WWDC 2026 for June 8th through the 12th. They're strongly hinting at major AI computational upgrades across the entire iOS platform. They're bringing massive onboard intelligence upgrades to macOS and Siri too.
The current industry rumors point to deeper Gemini and Codex integration structurally. Apple clearly wants to integrate these predictive models directly into their physical devices. This actively creates a persistent, highly personalized memory ecosystem right there on your phone.
We also have to look closely at rapidly emerging AI coding platforms today. A fascinating startup called Lovable is actively seeking massive industry acquisitions right now. They successfully built what they proudly call a vibe coding software generation platform.
The vibe coding essentially means you no longer write traditional syntax line by line.
Right. You simply describe the vague vibe or intent of the app you want. You say you want a modern app with a dark mode aesthetic layout. You tell it to make the digital buttons feel rounded and highly responsive.
The AI instantly translates those vague vibes into perfectly functioning back-end code. It's actively democratizing complex software creation for people without any formal coding background.
And they're currently hitting 200,000 daily software projects on their platform.
Let's put that staggering daily project number into proper contextual perspective. There are only about 30 million professional human software developers operating globally today. Lovable is independently generating hundreds of thousands of new software projects every single day.
They're racing aggressively against major competitors like Cursor and Replit to scale quickly. Lovable is currently valued at an impressive $6.6 billion internally. They're actively competing with major AI labs to scale much faster globally. The entire tech industry knows persistent digital memory is the ultimate corporate moat.
Why are tech giants fighting so fiercely for our personal digital memory?
Because controlling your historical context means completely owning your daily workflow entirely.
Owning past context guarantees control of future digital habits. 2-sec silence. This naturally brings us to the very sobering ground-level reality today. Billionaires are actively building massive $100 billion investment funds right now. Tech giants are aggressively warring over global persistent digital memory ecosystems daily. But how are these fundamentally unrestricted powerful tools actually being used today? How are they practically functioning out there at the local ground level?
The reality on the ground is often much darker than the shiny corporate pitch. We have a highly concerning factual report included in today's stack of sources. 2 teenage boys recently created explicit AI deepfake pornographic images online. They quickly generated 347 distinct deepfake images of their young female peers. This specific, highly troubling incident targeted 60 young girls at a private school. It happened recently at a very prominent private school in the United States.
The artificially generated content was widely shared on Discord for several months, unnoticed. Beat. We must state very clearly that we're remaining completely impartial here today. We're simply conveying the specific factual events strictly detailed in the source material.
Exactly.
We're definitely not taking any moral or political sides on this highly sensitive issue. We're simply looking objectively at the rapid societal deployment of this powerful technology.
Right. We're just critically examining the raw friction of this rapid software deployment. The totally unregulated deployment of AI generation clearly has severe local community consequences. These highly advanced image generation tools are completely unrestricted at the individual user level. Anyone with a basic internet connection can easily access open source image generators today.
The pure speed of this technology fundamentally outpaces local community governance structures completely. It completely bypasses traditional school boundaries and previously established local legal frameworks. Let's look closely at how this extreme societal friction plays out in reality. A massive tech company heavily updates an open image model on Monday. That specific model instantly becomes globally available to millions of anonymous users online. By Wednesday, teenagers are actively generating highly explicit, carefully targeted local digital content.
The local school administration typically operates on a totally different timescale than Silicon Valley. They have to carefully schedule slow community board meetings to thoughtfully discuss new policies. They have to meticulously draft complex legal responses to totally unprecedented digital situations locally.
And by the time the school acts legally, the generated content has already circulated. The sheer developmental velocity of the software completely overwhelms traditional human institutional speed.
There's currently no global regulatory bodies slowing down these massive open source tech companies. They're clearly prioritizing rapid software deployment over localized community safety and institutional stability.
The inherent friction between global technological scale and local institutional control is truly immense. You simply can't easily put these digital guardrails back up after the initial fact. Once the raw model is entirely public, the severe local impact happens almost immediately. Traditional school boards can't actively regulate a globally distributed open-source software generation model.
Exactly.
How does this extreme local friction impact the broader AI scaling race globally?
It creates a severe institutional collision between rapid global deployment and slow local governance.
Global deployment speed is crashing into slow local community rules. 2-sec silence. To fundamentally prevent these catastrophic system failures, the underlying computational architecture must urgently change. We're moving rapidly into the highly complex, multi-agent framework architecture right now. We're finally moving completely away from single, highly overloaded digital god models.
Right, we're rapidly shifting toward highly structured, highly specialized teams of autonomous digital agents because single massive models frequently hallucinate when given overly complex operational tasks.
Think of the old single model AI, like a highly overloaded restaurant line cook. They're frantically trying to chop vegetables, grill heavy steaks, and wash dishes simultaneously. Eventually, that massively overloaded single cook is going to burn something very important terribly.
ByteDance just recently released a major structural computational solution called DeerFlow 2.0 globally. This is a highly advanced, open-source, multi-agent framework designed specifically for highly complex tasks. Instead of forcefully demanding one AI model handle absolutely everything completely alone, DeerFlow intelligently splits a massive user task into much smaller, highly manageable digital steps.
You provide one single prompt, and the internal system starts planning the execution automatically. It seamlessly executes the smaller digital steps and returns a perfectly structured final result.
Let's carefully walk through exactly how DeerFlow splits a hypothetical, complex user task. Imagine you directly ask the system to research a specific company and write an article. A massive single model would desperately try to actively browse, synthesize, and write all simultaneously. It would highly likely mix up critical facts or completely hallucinate quotes during the process.
The DeerFlow cleanly intercepts that initial prompt and immediately assigns a dedicated planning lead agent. The lead planner creates 3 completely separate digital workers for this highly specific research task. Agent 1 is strictly instructed only to safely browse financial reports and extract raw data.
Right.
Agent 2 is strictly forbidden from actively browsing the live internet at all globally. It only formally formats the previously extracted data into a clean, highly structured text outline.
And then Agent 3 smoothly takes the structured outline and beautifully writes the final, polished narrative draft. Because each specific digital agent has a single, strictly isolated job, the overall error rate plummets. These specialized digital subagents quietly run in completely isolated digital software environments internally.
They have totally separate contextual windows and totally separate digital computing tools available. The technical sources specifically mention they securely operate safely inside a Docker sandbox. How would you clearly define a Docker sandbox for us in plain English today?
A secure digital room where code runs without breaking your broader operating system.
That makes absolutely perfect sense for securely isolating unpredictable AI agent tasks safely. If one specific digital agent fails totally, it doesn't crash the entire operating system. They also cleverly use Markdown-based skills for these completely isolated digital worker agents. Markdown is genuinely just a very simple way to clearly format plain text documents logically.
Yeah, these simple text skills clearly define highly repeatable, deeply structured workflows for the AI teams. The internal framework fully supports multiple major AI foundational models simultaneously right now. It actively supports GPT, Claude, Gemini, and DeepSeek APIs, smoothly working together seamlessly.
You can easily actively mix and match different advanced models for different internal subtasks.
You could effectively use Claude for creative writing and DeepSeek for the highly complex coding.
I see this functioning exactly like a highly efficient, well-run corporate team structure. Everyone definitely has a strictly limited scope and the perfectly right tools available. You're definitively no longer relying on one single, highly unpredictable, overloaded genius. You systematically rely on highly specialized digital workers doing parallel, highly specific operational tasks efficiently.
Exactly. This structured hierarchy makes multi-step software automation significantly more stable and inherently reliable today. Other major global tech companies are aggressively following this exact same critical architectural pattern right now. Tencent recently embedded OpenClaw directly inside their massive WeChat platform as a tool called Clawbot.
Daily users can now easily control highly complex daily tasks via simple WeChat text messages. Alibaba and Baidu are aggressively launching their own similar autonomous multi-agent systems too. The entire massive Chinese technology sector is battling fiercely over these highly specialized digital agents. Why exactly is parallel agent thinking the definitive future of AI system stability overall?
Breaking massive tasks down inherently safely isolates potential digital system failures completely.
Small parallel tasks prevent catastrophic single-model failures entirely today. Sponsor Rico's here. Let's intelligently take a quick moment to seamlessly bring all of these different threads together. We've actively covered a truly massive amount of conceptual technological ground here today.
We absolutely have. We carefully traced artificial intelligence's massive physical global expansion through Halter's innovative smart cattle collars. That clearly represents 7 billion massive hours of highly invisible, purely physical animal behavior data. We thoroughly saw massive tech giants aggressively warring over your highly personal, permanent digital memories. We objectively examined the incredibly sobering daily reality of localized, largely unregulated AI technology misuse. And all of this fundamentally culminates in massive multi-agent firmware computational architectures today, globally. Systems exactly like DeerFlow are purposefully designed to actively manage this immense computational scale responsibly.
The entire foundational layer of global digital computation is actively shifting violently beneath us. I strongly want to leave you with one final highly provocative thought to slowly mull over. If global artificial intelligence is rapidly shifting to entirely autonomous multi-agent structural systems now,
Yeah.
what exactly happens when Apple's internal OS agents start aggressively talking outwardly to the wider world? What exactly happens when ByteDance's internal subagents meet Halter's physical cowgorithms on a public digital network? Imagine them constantly aggressively interacting with each other out there dynamically in the digital wild. Imagine them efficiently doing this completely unsupervised by any actual human oversight or direct intervention.
Yeah, that's a wildly complex and incredibly fascinating technological future to creatively imagine.
Take a quiet moment today to deeply reflect on your own complex daily digital workflow. Are you stubbornly still trying to casually use AI as one massive, highly overloaded singular tool? Or is it finally truly time to systematically start splitting your own complex operational tasks? You should probably actively start distributing your complex daily work across multiple, highly specialized digital agents. Thank you so much for thoughtfully joining us on this fascinating deep dive exploration today. We'll definitely see you next time with more crucial technological insights and structural analysis. Music.